Alright, well, we've made it through atoms, the periodic table, and we're going to start talking about chemical bonds, and specifically ionic bonding. There's two types of bonds. There's ionic bonding that we're going to talk about today, and there's also covalent bonding that we'll be talking about later. So, a couple questions here to sort of go through. What electron it's kind of a review actually. What electron configuration do atoms require to be stable? And as we've talked about in class before, basically they want to have full outer shells. And that makes atoms stable. Helium, for example, has a full outer shell. All the noble gases have a full outer shell in row 8. So basically, that answers question number 2 also. If you looked at the periodic table, the entire row 8 or 18 as it's referred to in your textbook is stable because they have a full outer shell. Again, helium only needs 2 to be full because it only has one valence or one outer shell. The rest of these need 8 electrons to be stable. Well, what do atoms do when they don't have a full outer shell, which is really most of the elements on the periodic table? Well, they're not stable, so they usually find ways to become stable, and the way they do that is they actually react with each other. So a chemical reaction will occur where they will combine with each other to form either a compound, which is really what we're talking about today when we talk about ionic bonds, or they'll form molecules, which is just the other word we use when atoms join together to become stable, and the other kind of bonding that we'll talk about another day. So really today we're going to talk about ionic bonding, and specifically when 2 or more atoms come together to form compounds. So I sort of addressed it in question number 3, but basically what is it called when atoms try to get a full outer shell to become stable? In general, it's called the Octet Rule, where octet meaning 8, where the outer shell tries to get 8 valence electrons to become stable. The exception, of course, with helium and hydrogen, they only need 2, but we usually still refer to it as the Octet Rule. So trying to get 8 valence electrons to be stable. So what's an ionic bond? And that's a specific kind of chemical bond, and it's basically when atoms lose or gain electrons, and that puts a charge on the atoms, an opposite charge on the atoms. One will become positive, the one that loses the electron becomes positive, the one that gains the electron becomes negative. And that makes them join together because they have an opposite charge. The way I'm going to use this tutorial is I'm just going to explain in more detail what ionic bonds are using some of the rest of the handout. However, if you feel that you need to review specifically what ionic bonds are, then there'll most likely be a teacher version of the notes up over ionic bonding that you can also download. So hopefully that helps. Actually, before I go on to the next thing, I probably ought to say also that ionic bonds typically form between metals and nonmetals. And there we go. Alright, let's see how we do here. Let's take a look at this and fill in the blanks as we go. So ionic bonds form between metals and nonmetals. Metals and nonmetals. They will either give away electrons or accept electrons. This makes one atom have a positive charge and the other have a negative charge. These opposite charges cause the atoms to be attracted to each other, and forms a stable ionic bond. Group 1, remember they have one valence electron, will form ionic bonds with group 7 or 17 on your periodic table. Group 2, remember they only need one. Group 2 will form ionic bonds with group 2 valence electrons, will form ionic bonds with group 16 because they need to. To name a new compound, basically just name the metal first. For example, if sodium was the metal and the chlorine was the non-metal, you would just name it sodium chloride. So you just change the second name to IDE. Okay. Alright, this is meant to be practice because you can't really make ionic bonds until you understand some of the basic stuff in this chart. So this chart will help us set up information that will later help us to make ionic bonds. So let's cruise over here to bromine, the first one on the chart. Find bromine on the periodic table. A couple things I want you to note. Atomic symbol is Br. Has an atomic number of 35. That means it has 35 protons and 35 electrons if it's neutral. And it's in row 17 or 7, so that means it has 7 valence electrons. Alright, let's use that information to fill out what we have over here. Alright, so bromine. Atomic symbol Br. Total electrons 35 because the atomic number is 35. So 35 protons, 35 electrons. Valence electrons, it's only going to have 7 valence electrons. Not quite a complete outer shell. Remember, it needs 8 to be full. Electron dot diagram. Zoom in here when I do that. You're going to write Br, and you're going to put your 7 valence electrons. 1, 2, 3, 4, 5, 6, 7 valence electrons. And how many electrons is it going to lose or gain? Well, it would like to have, it doesn't want to give up 7, right? It's harder to do, so it's going to want to gain 1 electron. So it's going to want to gain 1, and that will give it a full outer shell. But when it gains that 1 electron, the charge on the atom is it's going to have 1 extra electron now. So the charge on the atom has 1 extra negative charge compared to the number of protons, so it's going to have a charge of -1, also known as an oxidation number. Alright, let's do one more together. Let's do lithium. So let's find lithium on the periodic table. Lithium's right here, right? It's going to have 3 protons, 3 electrons. It's in row 1, so it has 1 valence electron. Alright, let's see what we got over here. Alright, so lithium, we're going to abbreviate it Li. It's going to have a total of 3 protons. Valence electrons, it's in row 1, 1 valence electron. Electron dot diagram, we're going to write lithium, and it's just going to have 1 valence electron. There it is. And number of electrons lost or gained. Remember, it has a full outer shell underneath of that 1 extra electron, so it's going to want to lose 1. And if I lose 1 negative charge, it means I have 3 protons and 2 electrons, so I'm going to have a charge of +1. Alright, that should help you finish that chart. We'll see how you do on the rest of it. Go ahead and pause the video and do that now. Okay, now we get to actually practice making some ionic bonds. And the way you're going to do this is, we're a little limited on the kind you're going to make, but basically you can pick anything from row 1, and because it has 1 valence electron, you can combine it with anything from row 17. Or you can pick anything from row 2 and combine it with anything from row 6, because this one has 2 valence electrons, that one has 6. That can give up 2 electrons and give it to this row. Likewise, This has 1 valence electron. This has 7. It can give up 1 and give it to this row. And don't forget that these right here have full outer shells underneath their valence electrons, so they're stable once they give one up. And these will get full outer shells when that happens. This will put a plus charge on these atoms over here. Plus charge over here because it's giving up an electron. It'll put a plus 2 on these over here, and that will put a negative 1 on these over here and a negative 2 on these over here when they accept the electrons. So that forms the charges, and then they would join together. So let's just practice this. Alright, I did circle hydrogen in that. We're going to not include hydrogen when we make these. So let's pick 2 atoms to bond together here. Start with row 1 and 7 and make an ionic compound. So, let's zoom in here. Let's just make something simple here. Let's make a lithium. So we'll use lithium. And we need something in row 7 to join it with. How about we make lithium... how about lithium bromide? Okay, lithium bromide. So let's go up and make some lithium bromide. So the first thing you're going to do is make the electron dot diagram. So you're going to zoom in here a little more. So we're going to use lithium, and we're going to use bromine. Okay, so electron dot diagram for lithium. It's going to have 1 valence electron, and I'll just put it right here. The name is lithium. It says lithium. And the charge, remember it's going to give away that electron, so it's going to have a plus 1 charge on it. Okay. Alright, let's try the same thing for bromine here. Electron dot diagram. It's in row 7. It's going to have 7 outer electrons. 1, 2, 3, 4, 5, 6, 7. And I'm going to leave the unpaired one over to the left side here, and you'll probably see why in a minute. Okay. Okay, chemical name is bromine. And the charge, remember it's going to gain an electron to fill its outer shell. It's going to have a negative 1 charge. Well, these two are going to form perfect compounds because one has a plus 1 charge and one has a negative 1 charge. And the name of the new compound is going to be lithium. And then you change the non-metal, in this case bromine, you make it end in I. So it's going to be lithium bromide. Alright, now we're going to make the electron dot diagram for the new compound. It's going to look something like this. You're going to give away the electron that lithium had to bromine. So what I'm going to do is I'm going to, in red, I'm going to write my lithium atom. It's going to give away that electron, so I'm not going to put an electron over it. Instead, what I'm going to do is I'm going to, since it gave away an electron, I'm going to put the charge that the atom has. It has a plus 1 charge on it, so it's a positive ion. And what I'm going to do is give that electron to bromine. So here's bromine right next to it. And I'm going to draw the electrons. So bromine is going to get 1, 2, 3, 4, 5, 6. It had its own, but it just got a new one, and I'm going to color coordinate that, the red one. So now bromine has a negative 1 charge on it. -1 charge. And that's what makes it a new compound. This is lithium bromide, and that's how you would draw it. Okay, let's try this again. Let's try, how about we pick calcium and oxygen. We'll make calcium oxide. Notice I had to pick one from 2 because it'll give away 2 electrons, and one from 6 because it can accept 2 electrons. So here we go. I'll stick to my same color scheme. So calcium has 2 valence electrons, and it's called calcium. It's going to want to get rid of those 2 electrons, which means it's going to have a +2 charge on it. And oxygen has 6 valence electrons. 1, 2, 3, 4. I'm going to leave the left side blank since that's going to accept the 2 electrons, and just put it like that. Right? And calcium's going to give those 2 electrons to oxygen. Oh, by the way, I've got to name this oxygen. And it's going to have a -2 charge. So those 2 atoms will bond perfectly together. This is going to be called calcium oxide. And electron dot diagram. So we're going to have calcium give away 2 electrons. It's going to have a +2 charge on it. It's going to give those to oxygen. So let's draw oxygen over here. 1, 2, 3, 4, 5, 6. And calcium just gave them away. So let's give them over here to oxygen. And that gives it a negative. Switch back to blue. -2 charge, which makes those perfect compounds, calcium oxide. Alright, thank you for watching the tutorial.